have the apparatus we use for simple distillation. There are some features in the setup that are important to pay attention to. First, the clamps on the ring stand should be tight and facing forward. The clamp holding the small round bottom flask should hold the neck of the flask in place tightly, and the clamp stabilizing the thermometer should be loose. The thermometer is held in place with a glass thermometer holder with a neoprene attachment. Note that the inner, lower surface of the distilling head should be in line with the upper half of the thermometer bulb. The distilling head attaches to the distillation adapter, and all ground glass joints were put together after being lubricated with a small amount of vacuum grease to create a seal and to ease disassembly. Rubber bands are used to hold the distilling head in place so it does not slide off. There are 2 tubes attached to the condenser for water flow. The lower one is where water will enter, and it will exit out the higher tube. The lab jacks will hold the slop bucket or receiving flask to catch the drops from distillation. The Bunsen burner should be placed a few inches under the pad sitting on the iron ring, and there should be a small space between the pad and the round bottom flask.
Now for a walkthrough of the simple distillation process. The liquid mixture added to the round bottom flask should be about half full with a few boiling chips in it to prevent bumping from occurring. The mixture contains dichloromethane and ethyl acetate, which have different boiling points. The CRC literature values for their boiling points are 39.8 degrees Celsius for dichloromethane and 77.1 degrees for ethyl acetate. In this case, the dichloromethane will boil off first. After the setup is complete, the Bunsen burner should be turned on by starting the flow of gas and igniting a blue silent flame using a striker and adjusting the gas valve on the bottom of the Bunsen burner. Slowly heat the mixture to the first boiling point. The correct amount of heat is being applied if there is a drop of condensate forming or sitting on the bulb of the thermometer at all times. This allows for the most accurate reading of temperature. The slop bucket on the lab jack should be under the end of the condenser to catch the forerun, which are any drops that occur before the boiling point of the low boiling solvent due to any low boiling impurities present in the mixture. When the temperature is steadied out, the mixture is visibly boiling and there are steady drops of liquid coming out of the condenser. Remove the slop bucket and begin collecting the liquid with a small Erlenmeyer flask. Ensure that the flask is sitting just below the tip of the condenser to minimize evaporation. This liquid should be pure dichloromethane. Collect the drops until there is a sudden spike or drop in temperature, as this indicates that the first liquid has finished its distillation and is no longer present in the mixture. The boiling points will be represented as a temperature range starting at the point which the first drops of liquid were collected in the Erlenmeyer to when the last drop was collected. Replace the Erlenmeyer flask with the slop bucket to collect the forerun as the temperature rises further. Once the temperature is steadied out once again, replace the slop bucket with a new Erlenmeyer flask to collect the second liquid being distilled. Again, record the boiling point as arranged from the first drops collected to the last. Make sure you collect enough of the second liquid, in this case ethyl acetate, without running the round bottom flask dry.
It is important to know the atmospheric pressure of the area before determining the boiling point of a liquid. The boiling point of a liquid is reached when the vapor pressure is equal to the atmospheric pressure. When elevation increases, atmospheric pressure and boiling points will decrease.
To test the purity of both distilled liquids, we use gas chromatography. This is a separation technique in which gas is used as the mobile phase and a packed column is used as a stationary phase. From the gas chromatography, a digital record of the results called a chromatogram can be obtained. Using the chromatogram, you can tell if the liquid you tested is pure by the number of peaks present. In most cases, one peak corresponds to one liquid. Therefore, if the liquid is pure, only one peak should be present on the chromatogram. Another way to test for purity is by using IR spectroscopy. Using an IR spectrum, you are able to identify bonds that are present in a molecule, as certain bonds form peaks at specific wavelengths in the IR spectrum. If extra absorptions in the spectrum are noticed, this indicates that the sample is impure.